Right, second subtopic, which is on refraction at a spherical surface. So in this subtopic, you just have to be able to use this equation for spherical surface. Okay, so make sure you notice the difference. Just now it was a mirror. Now it is, wait, it's basically just surface, right? Oh, okay. Never mind, everybody. But basically this one is, it didn't mention that it is a mirror. It just basically mentioned that it is a surface. So any surface lah, right? Okay, so let's recall our prior knowledge. We know that refraction is the bending of light. Okay, so instead of reflection just now, tadi dia reflex. Sekarang dia bend. Okay, so this is the bending of a light when it enters a medium where the speed is different. Okay, so the speed is different. So we have what we call an index of refraction, which is small letter n. It is the description of the speed of light in a medium. Okay, so the greater the value of the refractive index. Okay, so I have spelling error here. Refractive index of a medium, the greater the bending effect of light when it passes from air into that medium. Okay, so light traveling from denser medium to less dense medium will bend away from normal, whereas from less dense to denser medium it will bend towards the normal. Okay, so that is the prior knowledge that we have to know lah. Okay, kalau kamu ingat, apa sebab saya sudah tambah dalam nota ni. Right, so okay, so this is the index of refraction punya formula, where C is the velocity of light in vacuum and V is the velocity of light in the medium. Okay, right, so let's look at the refraction at spherical surface. Refracting, I think it should be refracting. This is when my word unable to detect spelling error. Jadi saya tidak terbaca balik. Okay, so a refracting surface is the part of a sphere separating two transparent medium. Okay, so the spherical refracting surface ada two types, which is convex spherical refracting surface. This is the convex spherical refracting surface, and this is the concave spherical refracting surface. Okay, so ni adalah the first medium, and then the second medium ni dia bukan air lah. Sometimes this is air ataupun dia immerse in liquid ka, macam tu lah. Tapi this is the refractive index lah. Okay, so let's look at the equation that we will be using. The equation is n1 over u plus n2 over v equal to n2 minus n1 divided by r. Okay, where r is the radius of radius of curvature of the spherical surface lah, right? So that is here, and in exam they would usually give you the value lah, right? So every time kamu jumpa diagram yang lebih kurang macam ni, this is basically spherical surface. Okay, right, so sama juga for magnification pula, the only difference is there is a modulus here, and we have to consider the value of refractive index, right? Okay, next, the quantity sign convention there untuk u, which is the object distance. It is real when the value is positive and virtual when it is negative. Image distance pula real bila dia positive and virtual bila dia negative. So this radius of curvature pula, ingat there's a difference between this and the mirror punya. Okay, so the radius of curvature will be positive if it is a convex surface and negative if it's a concave surface. Okay, if you remember, for mirror, the focal length is gonna be positive for concave, meaning that the radius of curvature will be positive. Okay, so kita tengok balik untuk spherical surface pula, dia cakap convex surface yang positive. So maksudnya di sini bila ini positive convex surface, dia punya focal length will also be positive, right? Adakah kita guna itu? Oh, actually, we don't have focal length for spherical surface. I think lah, sebab spherical, that equation is just for real object. Oh, okay. Teda, just ignore what I've mentioned earlier. Okay, tapi kamu perlu ingat radius of curvature tu lah. Okay. Alright, so basically this table is again very important. Let's look at example now. So example number 2, we have a coin that is embedded in a solid glass sphere with radius 30 centimeter, and the refractive index of the glass is 1.5, and the coin is 20 centimeter from the surface. Alright, so which one is our first medium? So basically the object is where the light originated from lah. Okay, light is originated from the object. So the incident ray is from the object itself. So I'm just gonna use yellow. So for example, it's gonna be like this and then go towards our eye, refracted towards our eye. Basically, dia kita nampak lah kan. Okay, so which one? This is basically we need to determine what surface is this. Okay, so this is a concave surface, and the first medium is the glass, and then the second medium is air, right? Okay, so now let's just write down the formula for the spherical object, which is n1 over n1 over u plus n2 over v equal to n2 minus n1 divided by the radius of curvature. So what I'm gonna do is I'm gonna just list down everything. So we have the first medium punya refractive index, which is the glass, which is equal to 1.5. Next, what is the second medium? It is air, so that is just 1.00. This is air, this is glass, right? So we have n1, n2. Now we are looking for the image distance, which is v. So what is the value of u? U is the object's distance from the mirror, so that is 20 centimeter. Since it is in front of the mirror, it's gonna be positive. So that is positive 20 centimeter. Okay, so we have all of this. Now we just have to find r. So r is also given, which is the radius of curvature, and this is a concave surface. So for a concave surface, the radius of curvature is gonna be negative. Okay, so it's gonna be negative 30 centimeter. Right, so we have everything. Just don't forget to convert this into meter. So that is just 0.2 meter. This is negative 0.3 meter. Okay, so now bolehlah kita substitute dalam ni to find the image distance. So n1 is 1.5 divided by 0.2 plus n2, which is 1 divided by v, which is what we are looking for. And then this is 1 minus 1.5 divided by the radius of curvature, negative 0.3. So the image distance will be equal to negative 0.171 meter. Okay, so that is the object distance. The image distance. So if the image is negative, it is telling us that the image is virtual. Right. Next, we have to state the location of the image. So the image is virtual, meaning it is formed as the same side as the object. So kalau negative tu maksudnya virtual maksudnya the image is formed at the same side as object. So location dia adalah same side as the object. Okay, so that's just how you would answer this question. So again, what I want to emphasize is just list down what information that we have and what we don't, because it will basically kamu ikut the equation lah, formula yang kamu akan guna tu kamu list down. Cukup ke tidak information untuk kita cari apa yang perlu dicari. Macam tu lah. Right? Okay. Yeah, so that is that. Let's look at example number 2 pula. Example number 3. We have a cylindrical glass rod in air. So this is in air, has a refractive index of 1.52. Right, so again, this is a spherical surface. I'm just going to start with the equation itself. So the equation given is N1 over U. You can also write it as NA ka untuk just to let you know that it is air. But I'm just going to use 1 lah, N1 over U plus N2 over V equal to N2 minus N1 divided by R. Okay, so let's just find the value of each of these variables. Okay, so this is asking for V lah, position of the image, 10 centimeter to the left of the pole. Right, so let's just ignore that for a while. Okay, so now given is the refractive index of air. So this is the first medium because the light is originated from the object. So this is our first medium, which is air. So N1 is gonna be equal to 1.00. Next, what is the second medium? The second medium, it is a glass sphere which has a refractive index of 1.52. Right, so next we have to determine the object's distance from the pole. So that is 10 centimeter. That is just 0.1 meter. Wait. Let me just... Oh, okay. Betul lah. 10 centimeters, sorry. So that is 10 centimeters, 0.1 meter. And then V is what we are looking for. Now we have to find R. R is given here, which is 3 centimeters. So that is 1, 2, 3, 0. 0.03 meter. Oh, wait. We need to know the sign convention. So the object pun is in front of the mirror. Not mirror. Okay, that is a problem. Okay, in front of the surface. Front side. Okay, so dia akan positif lah. Usually U ni memang akan positif unless dia cakap dari sini lah, at the back side. Okay, unless. So radius of curvature, this is what type of surface is this? Okay, so dia tengok dari the object. So from the object, dia pergi di sini. So what is this? This is a convex. So convex radius of curvature dia adalah positive. So it's gonna be positive 3 cm. So 0.03 lah. Positive 0.03 meter. Okay, so we have everything. So we just have to substitute that into the formula there. Okay, so that is 1 divided by 10 centimeter, which is 0.1 plus N2. N2 is given as 1.52 divided by V, that is 1.52 minus 1 divided by R, which is 0.03. So from here, this is gonna be equal to positive 20.7. Sorry, we want it in meter. 0.207 meter. So that is the position for the image. Okay, this one ni maksudnya dia just bagi tahu the object is 10 cm from the pole, to the left of the pole. Begitulah. Okay, so next we have to calculate the linear magnification. So where is it? Okay, so the linear magnification is just this equation here. So we are going to use this one because we do not have this information. Right, so M is equal to modulus N1 U V kan tadi tu, V over N2 U. Okay, so dia ada modulus. Basically dia mesti positif lah. Okay, so this is 1.00, V is 0.207 divided by 1.52 times with u, which is 10 centimeters, 0.1. So the magnification value is 1.36. Okay, so magnification theta unit. So that is the magnification of the image. So it is greater than 1, telling us that the image is magnified. Right, so that is all for subtopic number 2, which is on refraction at a spherical surface. So make sure you know the steps on how do we solve the problem using this equation, and please remember this sign convention here. Right, so that's all for subtopic number 2.